All right, so some bonus material for section 9.4. We're going to start by multiplying some radical expressions. That means that this number on the outside has to multiply both of those numbers on the inside. Let me write it out very carefully. 2 square roots of 7 times 6 times the square root of 35 plus 2 square roots of 7 times 3 square roots of 2. Now with these, the stuff that's on the outside is going to multiply and the stuff that's on the inside is going to multiply. So let me start with the easier of these two first. 2 times 3 is 6. 7 times 2 is 14. And that's looking good. No problem there. Over here, we're going to do the same thing. 2 times 6 is 12. And 7 times 35 is 245. Unfortunately, we're not done with that one. And that's where my list of perfect squares can come in handy. Want to look up 245. Now, 245 falls right between these two. And what you want to do is you want to work your way up the list to try and find something that goes into 245 evenly. So no, 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 no. And all the way here. Now, what you can do if you're like, well, I don't know, is you take 245 and divide it, say, by 81, and you'll see that on your calculator you get a decimal. It won't go in even. But if you do that with 49, 49 will go in there exactly 5 times. So it would look like this. 12 times the square root of 49 times the square root of 5 plus 6 square roots of 14. And that will simplify. So that's going to be 12 times 7 times the square root of 5 plus 6 square roots of 14. One of the more common mistakes I see is people taking the square root of this but forgetting to get rid of the square root. That is, they'll leave it as a square root of 7. That's wrong. So, whoops. 12 times 7 is 84, square root of 5 plus 6 square roots of 14. There's no perfect squares that go into 14, so we're done with that one. How's that first one look? Doing okay there? All right. Let's try another one. So, example B. Square root of 3x plus a square root of 3 squared. As tempting as that may be, please don't just square this and say, oh, it's 3x plus 3. It doesn't work that way. What you're going to have to do is you're going to have to multiply this binomial by itself. Square root of 3x plus square root of 3 times square root of 3x plus square root of 3. Let's see. There's nothing outside the radical. It's just kind of a 1, so we're just going to multiply what's underneath the radical. So it's going to be square root of 9x squared plus 3x times 3 is going to be 9x. Same thing here again. 9x plus the square root of 9. There's one just like this in your web assigned homework. Hopefully it has different numbers, but we'll see. Both of these terms are perfect squares. What do I get when I take the square root of that? 3. And the square root of this is going to be x. Now for a problem like this, they're probably going to tell you that, oh, assume the variables are positive. Because the variables are positive, I don't have to worry about the absolute value around this one. Normally you would, but you don't have to in this case. I'm going to take care of this one slowly. I want to do this first. There's one of them here and one of them here. That gives me a total of 2 of those middle terms. So 2 times the square root of 9x plus 3. But there's a little bit more work I can do with that middle term. Does anyone see what else I can do with that middle term?
You can take the square root of the 9.
Yeah, you can take the square root of 9. Perfect. Thank you. So square root of 9 and then square root of x. Square root of 9 will simplify. Square root of x just stays there. What's the square root of 9?
3.
3 times 2 is 6. 6 times the square root of x plus 3. And that is your final answer on that one. So we're just using the fact that this is 3. 3 times 2 is the 6. Beautiful. How are we looking on that one? Good, thumbs up, thank you. How about my homies? Anything on that one that's bothering you still? If so, please get some help. Reach out. Okay, let's keep going. A couple more here. I'm going to get you back to your work on section 9.4. How about square root of 7/8? So this will be example C. Square root of 7/8. Now there's a couple ways you can do this, but the thing is, mathematicians don't necessarily like radicals with fractions in them. So I'll break that up like this and say, oh, okay, cool. There's no fraction on my radical. Well, then if you look through the book carefully, you'll see that there's some other point that says, well, we don't like radicals in the denominator either. So at this point, you actually have to do some work. And I'm going to split this up first into 2 radicals. How about the square root of 8? Is there anything I can do to simplify the square root of 8?
2 times 4.
2 times 4. Perfect. So I'll put the 4 here and the 2 here. That gives me square root of 7 over 2 square roots of 2. Well, I'm still stuck with that square root in the denominator. And I said just a minute ago that mathematicians don't like square roots. So we're going to what's called rationalize this radical. Now, the way I can rationalize it is to multiply it by 1. Now, if you remember back, multiplying by 1 doesn't really change anything. But if I'm clever about the way I choose my form of 1, I can actually make some progress. What if I multiplied it by the square root of 2 over the square root of 2? Do you agree that in effect it's multiplying by 1? Something over itself is 1. But instead of canceling, the square roots like this, I'm going to multiply 2 times 7 to get the square root of 14 underneath the radical. What's going to be underneath the radical here?
4.
Yes. So I'll get a 4. So square root of 14 over 2 times what? Somebody help me out with the square root of 4? I don't have my calculator handy. 2. Thank you. So you should end up with a square root of 14 over 4. That should be equivalent to square root of 7 over 8. Let's see that that's indeed the case. So let me clear out some stuff here. Clear that. And let's compare the square root of 7 divided by 8 with the square root of 14. And you got to be careful here. You got to exit the radical. So I got to get out of there and then divide by 2. And that should be exactly the same thing. Oops. Where did I make a mistake? Oh, I know why I made a mistake. That should be a 4 in the denominator, right? The 4 there. Perfect. Now let's see. Whew. All right, my faith in math is restored. Good. One last one here, but it's a doozy. So grab a deep breath, and let's charge on for example D. Now, example D is going to require some of this kind of stuff, where we're going to have to multiply binomials together. And it's going to also require a little bit extra. So let's see what's going on with example D. Square root of 5 minus square root of 2 over square root of 5 plus square root of 2. Well, kind of like the one above, this one's got radicals in the denominator. And I can't solve my problem by multiplying by just square root of 2 over square root of 2 or just square root of 5 over square root of 5. It just won't work. I am going to multiply by 1 somehow. Square root of 5 plus square root of 2. The thing to keep an eye on is the denominator. And what you're going to multiply by is something called the conjugate. So the conjugate of the denominator is really going to be the same thing except the opposite sign. So what I'll have here, instead of square root of 5 plus square root of 2, I'll have square root of 5 minus square root of 2. And notice it's the same for the numerator and the denominator. Problem like this is pretty much a guaranteed lock for the exam. This is one that I just don't miss, all right? So, do you get the trick of what I'm going to choose? It's going to be the conjugate of this term in the denominator. You can ignore what's in the numerator when you're determining what you're going to multiply by. It's going to be the conjugate of the denominator. And that term has to be identical in the numerator and denominator so that we're multiplying by 1. Now, lots of multiplication here. Let's have at it. In the denominator, square root of 5 times square root of 5 gives me square root of 25. Minus square root of 10. How about the middle term? What am I going to get there when I multiply these two together? Square root of 2 times square root of 5 gives me
Square root of 10.
square root of 10. And it's a plus square root of 10, right? It's a positive square root of 10. And the last term, what sign does the last term have?
Negative.
Negative, perfect. Negative square root of 4. Now, if you're watching at this some later date, maybe you want to pause the video and see if you can't figure out what the numerator is going to look like. And that's a little tricky. But there is some nice cancellation in the denominator. There's a lot of cool simplification. Let's start here. Minus square root of 10 and plus square root of 10. Those cancel. Nice. In the denominator, square root of 25 is 5, square root of 4 is 2. So the denominator is simplified down pretty nicely. It's just going to be a 3. But how about the numerator? Basically, you're going to get the same terms, it's just the signs are going to be different. It's going to be square root of 25 minus the square root of 10, and leave a little space there. Minus, again, leave a little space, square root of 10 plus the square root of 4.
So the signs just split. Well, no. Not all of them. Never mind.
It's okay. It's all right. But maybe what you're seeing is the fact that, wait a minute, these two don't cancel like they did in the denominator, right? Because they're opposite sign, or they're the same sign. So let me put a 1 in front of each of these. And as tempting as it is, when you combine these, you do not get the square root of 20. You do not. You're going to add up the coefficients. So,
say negative 2 square root of 10?
Yep, negative 2 square root of 10. Excellent. Negative 2 square root of 10. And over here, I get a 5, and over here, I get a 2. Now, this square root and these numbers have nothing to do with each other. I can't do 5 minus 2 because that 2 is multiplying the square root of 10. So I can add these together. 5 plus 2 gives me 7 minus 2 square roots of 10 over 3. And that's your final answer. You could write it as 7 over 3 minus 2 square roots of 10 over 3. I'd accept either one. Sometimes if you write it like this, you can pick up a little extra simplification, but either one works. How are we looking there? Doing okay?
Mm-hmm.
Big thumbs up. Excellent, excellent. All right, let me cut things loose here, and you can keep working. Good luck.